Unfortunately, I had this all prepared for a little bit of group interaction. I'm going to have to curtail that, and we're just going to have to roll through the slides in order to hit the time schedule. That was a big surprise to me. But what you have in your hand is probably the best thing that can happen from this presentation. So there is a handout here, and you can download this off of the Speaker Bureau for ADM, for ConExpo. But also, just in case it wasn't working, I wanted you to have these things right here so that you could reference it. That may be one of the best things that comes out of my presentation. The other thing that I think, and I'm very committed to this, that I think is of value, is the world works in threes. And there are three things basically about equipment. There's three things about what we do. If you think about this, there's every key position in our asphalt industry, whether you're producing or laying, or you're doing compaction, or you're prepping a job. There is really kind of like three key things. It's about 80% of the action. In equipment, there's three levels of knowledge. And this really may be the best thing that I can provide you here. I just really want you to think about this a while, because this is, after 45 years, I think this is really true. And the guys that I work with every day, so I do consulting work. I've written a lot of stuff. What you see here on the screen is my own books on production, but I've been very involved with a lot of the stuff that's been written in the last 30 years. And it's broken into three things: principles of production, best practices of production, equipment management, and production. This is true for rollers, pavers, stacking, conveyors, crushers, whatever. I spent 5 years as an area manager working on custom crushing operations. So it's the same thing. Any machine that you get your claws on, any machine that you have, even in the lab, I'm working on a binder lab right now, but on a maintenance program, and we're struggling with some, chillers that run our PVRs, and I'm giving the same speech. Any machine that you get your claws on, there's three things. The first thing is, how does it work? That's the first book that I put together a number of years ago, Principles of Production. This is how we make that machine. But once you get that under your belt, the most important thing is, how do you run it correctly? How do you run this machine correctly? Same thing is true with a roller or a paper. It's like, oh, that's how it works. But how do you do it right? And what they asked me to do is put a presentation here about our best practices. Brett and I were thinking about, we were going to do two presentations. It actually got edited into one, and the second presentation was, how do you maintain it right? Buzz is going to be here talking tomorrow. He's going to be talking about forensics on pavements. Greg Reniger is going to be here from Aztec in the morning on the asphalt stage. At 9 o'clock, I'll be here. I've kind of seen this presentation already about efficiency in production, but it's like, if you don't, maintenance is a critical thing to maintain our efficiency and maintain the thing to operate correctly. If we ignore maintenance, we end up with a quality problem. I sent Buzz some slides, and he's with the Asphalt Paving Alliance, and you might know him. He used to be at Academy around Test Track. He retired from there. I was working for the Asphalt Paving Alliance, and he was in New Jersey making a presentation last week about how maintenance can impact mixed quality. And I thought we were going to weave that into our presentation, so you're going to get a couple shots over the bow later in my presentation on this. Okay? Because if we don't maintain our plants correctly, it won't work right. So first of all, you got to know how to work. Secondly, you got to know how to push buttons right. And the second thing is, you've got to maintain that thing. Otherwise, we're going to have a quality problem. Okay. Out of that second book on quality management and hot mix production, there's this chart. I think we shared it in years past, the World of Asphalt. These are all the bullet points of making good mix. This is not a 45-minute presentation. You can see all these bullet points here. You could really spend several hours. In fact, I could teach a whole one-day program on quality management and mix production. We started every piece of the plant. I've selected a few nuggets from that in this presentation. Back on 3, though, here's another key thing that I think you can take from me. And I see 1 or 2 equipment manufacturers in the room that build plants. Okay? Realize that in mix production, the quality of that mix production and running that plant right falls into 3 key people. And, who are they? They're the plant operator, obviously, but the loader guy is a key part of quality management. And the other thing is the person that is on the ground, key part in quality management. Now, this is my crew at one of my plants. I asked them to send me a picture of them, and Rachel, we're not really sure. You're going to say, well, what's the woman doing? We're not really sure. Okay? She's been learning how to run the plant. She can run a loader. All of these people can run every big thing. We've graduated several women, so there's a plug for women of asphalt here. We've graduated several women through our company. We have a very high percentage of females in our operation in Florida. And, they've left, graduated, moved, got married, and they're running plants and running loaders and even working on the ground, at other locations around the country. This is a really key career. There's only 3,600 asphalt plants in North America. A plant can feed anywhere from 4 to 7 crews. You multiply that, and we're looking at, over 10,000 paving operations easy, but it's in the hands of the 3,600 plant operators. Okay, you learn how to do this right in this program, and I'm off topic now, but you will never have to worry about working. And most of the people that we've graduated, brought up even from their 18, they're still in the business. It's a good industry. I've been in it for 45 years. Now, those 3 people are now going to be responsible for all these best practices we're about ready to talk about, right? And you can make a chart out of this. The person on the ground is a key person. He is the one that's watching the machine run, he's lubricating the machine, and he's inspecting that machine, and he can see things that are going sideways before the guy at the loader or the plant guy can feel it in his boots, standing in a 2-story control house, focusing on trying to load, 25 trucks out of 3 or 4 silos. Okay? So you can build a case that there's really more than 3 columns, and I am not really sure where the laser is, but I don't think I have one. So there's 3 functions that are critical: watching the plant on the run, on the ground, what the loader guy's got to play, and the guy on the console. So I call it on the console. He's the mix master. He's the chef. Okay? He's the chef. Loading trucks is a separate function, and a lot of times we use the operator to also load the trucks. I don't like it, which is why we have 4 people in our control houses a lot, because you can't watch the plane run if you're spending all of your time serving Cokes in the aisle. And you can spend all your time loading trucks and with your back turned, because that's the way we lay these stupid plants out. We have a loading thing over here so we can see the silos, and we have the burner control of the plant over here so we can see the plant. You got your back turned to the plant, and if the plant starts going haywire, you start losing altitude. Because running a plant is a lot like flying an airplane. We have automatic controls, yeah. Do you want the plane to automatically take off and fly to Las Vegas and land on its own without somebody who knows what they're doing sitting in the seat? Probably not. And that's the future of automation. Okay? So loading the trucks can be really, really hectic, and that might be a key thing that you take away from this little nugget here today, is that don't get sidetracked with the guy doesn't know where he's going, he's not sure what crew he's not even sure this is the right plan, he doesn't speak the same language you do, and his credit card doesn't work, right? So you don't have a lot of time focusing on, that's the real world. And you don't have a lot of time focusing on making quality bags. So we have that chart. Now, if we make it through 45 minutes to the end of this program, this is an entire other presentation, which is how to take care of the machine. Okay? And I've got what I consider to be, and a lot of people consider to be, and this is very important to hear. This is very important because I try to do everything colorblind. You take this chart on what you ought to look at every day, every week, every month, every quarter, twice a year, and you compare it to your operating manual from Barbara Green, Cedar Rapids that don't even exist anymore. Allmax, we got an Allmax guy sitting here. ADM, Aztec, Gencor, Amon. You're going to see these match. And unfortunately, in our management world, the people that run these plants, and I've been in this business 48 years, and I built plants for 30, I still do, I build custom stuff. They don't read the manual. Not a good idea. So, keep three key things. If you want to keep your plant online, here's 3 things you can do. Number 1, have an inspection program. Forget lubrication. You need to lubricate your equipment, but you got to look underneath of it, because a machine is going to wear out. It is going to wear out. Any machine you own is going to have to be managed to some degree from a maintenance standpoint, or you're not going to have a functioning chainsaw. You got to oil it. You got to sharpen it every once in a while, you got to change the spark plug, and you better put ethanol-free gas if it's 2-cycle motor, otherwise in the spring you're going to find it doesn't work because the O-rings are also worn out, right? Anything requires maintenance, okay? How it works, how to run it right, how to take care of it. The benefit of having the handout here, which people are listening to this, they can download it, is that I've done a lot of the hard work for you. There's the list. Once you have a list, think about this. Those of us that have been managers our whole life, and I didn't want to be a manager, I just ended up as a manager. I've got 2 degrees in management. They don't really teach you how to manage. Okay? Teach you a lot of tools. But the first thing about management is that you need to have a punch list of which you're going to manage to. You need to have a punch list of how to make mix record. And you need to have a punch list on what to look at and how to take care of it. So maybe that's the biggest benefit of you spending your time here, with me this afternoon. Now let's rip through some of the key points at a lightning speed on quality management. Start with the rock. The best producers keep the rock properly separated. No cross-contamination, blah, blah, blah. I don't have time to enumerate these points. You know this is true. This is what you need to manage. When things go wrong, and I have a whole other program, I think we did it a couple of years ago, when things don't work right, okay, it is usually because one of the basics got bent. And it's frequently, in my experience in this business, that it's not just one thing, it's 2 or 3 things. Okay, so this was wrong, that was wrong, boom, we got to dig up, a mile and a half of road. Okay? So the best practices here are properly separate the rocks, keep them free of contamination, pictures that show how to do that. You want to be on a solid draining surface for a lot of reasons. You don't want contamination from the ground. You want to get water out of the material. Every 1% moisture reduction is going to be 10% on your fuel bill. Your fuel bill is $1 million a year. It's $100,000. Okay. Shout out for Napa, who really sponsored me here. Is it 132 QIP? 132 we just did? 132 or 133 or 132? So there's a whole publication you can go downstairs and buy on QIP 132. It's about an energy management in your plant facility. Greg's going to be talking about this, I'm sure, tomorrow morning. And some of the slides that I have here will dovetail on what he's doing. Okay? Now, when you're feeding the plant, now that you kept it all separated, you stockpile it, right? Work the entire phase, key point. What that does is it averages out the gradation inconsistency, because you're going to find the gradations are inconsistent. The question is, how inconsistent are they? In other words, what's our standard deviation of our control system, right? That is critical. Here's another little thing to take with you as a soundbite. You can't make good asphalt the way we make asphalt in North America, which 95% plus of the high dollar owner agency work is produced through continuous mix plants. You go out here and look at it. We blend rock, we blend asphalt, we dry, we heat, we hit target temperature, we put it in a truck and pray we didn't segregate it. Okay, that's it. That's the way we do it in North America. They don't do it in other places around the world that way. They produce an 1/8 inch rock, a 1/4 inch rock, a 3/8 rock, a 1/2 inch rock, a 5/8 rock, a 3/4 rock, a 7/8 rock, a 1 inch rock, and a 1 1/8 inch rock. And then they blend it together. We built plants overseas, 14 cold feed bins, 12 cold feed bins. Here in America, we do that with like 5 aggregates maximum. Count on that. Okay? You have inconsistent stone, you can't make good asphalt. You can have consistent rock and still make bad asphalt. In other words, you can push buttons wrong. Garbage in, garbage out is what we say on the street. The loader guy's responsibility is this, and that's the column in front of you, because I've got to go fast here. So you work the whole face. You make a blend pile if you need to, and what you do is averaging gradation inconsistency when you make a blend pile. You feed dry material to the plant. There's an adage, stay up 12 inches. Here's a picture you can see of Papa over here trying to stay up a 1/2 inch. I shot that early in the morning one morning, and you only have 1 or 2 loader buckets in there, but he's up about 12 inches on that right-hand picture. Okay, and you can see the wet line between these 2 rock piles, the 1/4 inch minus and the 3/8 stone. You can see the water, you can see the visual wet part of that pile. That's where the water is sinking down. You don't want to feed that into your plant. Okay, so this allows us also to control temperature, as you will see here. So the best producers know their aggregates. Now there's a little sidebar comment here. This is not, I know I sound like I'm preaching. Number one, I love asphalt. I think it's a great choice, okay? But I have not learned this. This is not my own knowledge. This is me spending, I've been to hundreds and hundreds of plants in Oregon and worked with people and developed programs with them and helped them troubleshoot issues. This is what I've learned from people that don't have problems. This is your peers being successful. This is what they do. This is not my idea. This is the real world. This is how it works. So the best producers know what rock they have. Gradation is going to vary. They test material as it comes in, and they separate material into cells. In other words, you use the material into your feed bins, then you know what the gradation is. You don't take brand new material in, throw it in front of the pile, feed it in the plant, and find out you made a bad mix. Because somebody changed the screens at the quarry, and the screens are fatter now, and the holes are smaller, so the rock just fined up, right? That's what happens. That's the real world. You know, just a little funny story on that. We take rock into Florida from Nova Scotia with one of the big, aggregate firms. because there's no rock left in Florida, but a couple of quarries down around Miami. And, you know, they don't ship in the winter. When are you going to do maintenance on your quarry? In the winter, right? When are you going to change screens? In the winter. So I call Sherry up and I go, hey, there's a ship coming, 60,000 tons of material. You're going to unload it on a wharf wall. And I'm like, you know, and she goes, and she just starts laughing. She said, I was thinking about you this morning. And I said, okay, I'm thinking about you. What do you think we ought to do? She said, I think we better inject this rock when it comes in, because I'm pretty sure it's going to be finer than frog hair, you know? And it did. The control set moved 14%, but it's still in spec, because our spec band on aggregate's that wide, and our spec band on asphalt's about this narrow. Okay, that's the real world. And I said, yeah, I was drove by the rock, the wharf wall, and you got some space. I think you ought to put it in another pile. The half-inch rock moved 14 percentage points between the old pile and the new pile. Now, a good producer is on top of that, and he doesn't take brand new rock and throw it in and find out his mixed bed. Very simple concept. A lot of people don't do it. That's why I'm stressing the point. Okay? Now, you use blend sheets to create your mix design. You can use these blend sheets when you know the rock is different to change your cold feed percentages to keep your mix on target. And when you graduate, you're at that point. Okay? So you just make a proactive decision. Dave and I have an argument about it all the time. I say, Dave, I think we ought to move the blend this way. And he's the mix design guy. Well, why don't we make mix? I go, well, that's a great idea. Let's go ahead and make mix and then find out I'm right. I hope it doesn't affect our pay factor because we're in the bonus stage. Oh, yeah, well, maybe you're right. You know, because the old way of doing it, because he's an old fart, I'm an old fart, the old way of doing things is you just make mix and then figure out what's wrong with it and then you just adjust the plant. You know, there's an awful lot of plants that haven't been calibrated in 10 years. This guy's like, what? You start visiting plants and you have a mix problem and you just ask a simple question, when was the last time you checked your cold feed bins? When did you calibrate your cold feed bins last? I don't know. You know, when the computer went out, we had to change the motherboard. You know, they just look at the mix and it's too coarse, so we fine it up, and it's too fine, we coarse it up. That's the way it still goes on in this industry. That's why you're here at ConAgro. You don't want to be that way. Best producers don't do this. They know what it is before they feed it into the plant. I need to move on. Also, calibrations are going to move. They do shift. So the logical idea is to check your calibrations every once in a while to see if they've moved on you. A lot of people don't do that. Best producers do. Okay? So routinely check your plant calibrations. It's on your chart. Don't wait till the mix is bad, because usually it's an electromechanical problem. Okay? It's usually the fault of a machine. Okay? It only takes 30 or 45 minutes to test it, so being proactive is a great idea. Picture of that happening. If you're feeding material out of stacking conveyors, I left these in. I wish I could have taken them out for time. But the thing is that they're going to segregate. They're going to segregate by their very nature. Coarse is going to go to the far end of the pile. The fines are going to stay underneath the conveyor. So we feed perpendicular to the feed angle. So the conveyor's loading north and south. You're going to feed east and west out of that pile, and you're going to make a blend pile before you feed it into your plant. You know, that's best practice. And you go out there and you know, ConAgro here, and there's billions of these programmable stackers out there to look at. Okay. Now, you minimize the problem that creates by feeding perpendicular to the feed of the conveyor. Same thing is true with wrap. I left these slides in because most of us are running a very high percentage of wrap now. Asphalt is 100% recyclable. You are your own quarry when you process your wrap. So you have to manage your stackers and your equipment just like you were producing aggregate. You're in, as Kenny Monolith used to say, it's an urban quarry. We're an urban quarry. Okay? Programmable stacking conveyors help because It's a huge advantage for a lot of reasons. You can raise, extend, and articulate it. Actually program a stockpile, minimize your segregation. It only costs you about $500,000. Okay? Drastically reduce the segregation is great. Same thing is true rear rack. Okay? You can use anti-segregation head pulleys, which act like little badgers. That helps a lot. It's a big advantage. Again, the point is that you are managing the segregation issue. So here's a picture of a rock terminal. You can see this programmable stacker is moved out of the way. They've fed that pile this way, and the loader guys load trucks to go to an asphalt plant right and working that entire face. So again, working the face, blending the material, chucking it in the truck. Okay? Best practice. Okay? Same thing is true with racks. So here's threw these slides in because here's one of our plants. There's the wrap crusher in the back, it's red. There's the stacker. You can see the direction they're stacking the pile. They're going back and forth like this. You know, kind of, you're looking at the screen. Those of you who are listening to this can't see this photograph, or maybe you can, I guess you can. But it's going to be in the foreground. This thing is worked back and forth, and then he's laid another ridge in behind that. So the loader operator is going to come in and see how he's working the face perpendicular to the feed angle. You can see it right there in the picture. Okay, that's best practice for that. Good idea to have dividers to keep from cross-contamination. Calibrate your best practice, calibrate your feeders and dry weights, different speed ranges. This is important. So if I had to edit these slides down even more, I'd just say multiple point calibration. 3-point calibration should be your minimum on everything. Cold feed bins, belt scales, you know, asphalt meters, everything. Mineral filler additive systems, whatever. Just go out and ask all those manufacturers if 3-point calibration is a good idea, and they're going to tell you yes. Best producers do 3-point calibration. Other people just do 1-point calibration because it's usually linear, so why bother? I've heard this out of the mouth of people that work for me in 7 plants. We don't do that because if 25% feed leads gives you 25 ton an hour, 50% feed gives you 50 ton an hour, 75% feed gives you 75 ton an hour, you know that's a 45, you know, it's a linear function. And so the computer can, you know, interpolate between those points. A lot of computer systems, when you calibrate it, gives you a graph. Those are the ones I like. If that graph is not on a straight line, you got an electromechanical problem. Go fix it. Because it might be that you run the plant right where that hiccup is, and it's going to affect your mix. Linearity, proven linearity on all of your mixing ingredients gives you good mix. And I'm spending some time talking about that because there's going to be slide after slide coming up on belt scales and feeders on the same point. I can skip over, okay? Try to run your operations so that you're operating everything between 10 and 90% speed. Things don't like to go super slow, and they have a tendency to flatten out on the high end. It's better to stay in that linear range, which is what you see on the screen. Okay? Best producers do this. Make sure your on-off times are set right in your computer so your mix, when you fire it up, and it comes off the end of the belt, goes through the drum, it's good. Okay? Vibrators and air cannons in case you have loss of feed, making sure your no-flow switches work. Whose job is all this? The guy on the ground. The guy on the ground is going to watch the feed. The guy on the ground is going to keep an eye on everything, and the operator, because if he hasn't turned off all the automation, he can see it working correctly, and that point should become evident of you. Daily monitor the feeder flow just to make sure it's working right. That's the ground guy's job. Use set point timers to alarm if the control systems have it. I got news for you. They all do. You look in the left on this screen here, you know, they're running that plant at 200 ton an hour. The green thing says 200 ton an hour with a T target. The axle is 202.1 with an A, axle. If you put in 200 ton an hour and you get 220 ton an hour, you get a problem. And the lab's going to call you up and go, your mixer's not good. Okay? And so they're there for a function. The reason I'm stressing it is because operators like to turn these off. You know, when I set up, I've fired most of the people that I inherited, and they asked me to kind of run the company. One guy signed his death warrant the day that we had bad mixing and went to the control house, and I'm looking at the screen, turning the axles off, and I'm like, your speakers are unplugged. He goes, yeah, it keeps barking at me and it bothers me. I'm like, really? So I go over to the alarm screen, and there's 15 alarms in the alarm log. I'm like, dude, they're there for a reason. And I'm stressing this point because it's very common. I've audited over 600 plants in detail. I have a 45-page document that I do this with, and I've helped other companies build those inspection programs. We internally audit once a year, and it's very common for people to turn this off, and it just leads to it not working right. Okay. So good producers use set point tolerance alarm. They check their feed bins frequently. Storage, key points, monitor your temperature. Whose job? Brown guy. Monitor the temperature in every tank. Here's a picture of a tank, and on the left of the screen it shows the actual temperature. The other picture I had there is the hot oil heater system, an independent verification of the hot oil temperature external to the heater system, so that you know the heater system is set here and the actual hot oil temperature that's going throughout the plant facility is what you want it to be. Because we have to maintain liquid asphalt at a proper temperature to be a permanent coating. So you bring aggregate to the proper temperature to get proper, coverage. Asphalt control then is two things. Write this down if you haven't got this memorized. Asphalt only comes from two things in continuous mix plants: belt scale and a meter. Okay? Gradation is a calibration thing for the feeders. Asphalt content is belt scale and meter. Okay? So there's some best practices on the scale. Keep pulleys, pulleys for your buildup. Run your conveyor every day. Why? The speed changes. You know how long a 100-foot belt stretches in the first 20 minutes of operation? Over 8 inches. Whoa, that's why we have rapid take-ups to maintain a zero. So we want to make sure we got a zero when you start in the morning, and you want to make sure it goes back to zero. If you get buildup on your belt, it doesn't go back to zero. Your asphalt's going to be high throughout the day because it's measuring the weight that's not going into the dryer. Very common problem, okay? And it's part of our troubleshooting series. Use test weights if you have them. That tells you your scale's working right, okay? And recheck your calibration. Low, medium, and high rate again, all right? So this is back on the pumping system. Again, low, medium, and high rate calibration. Make sure it's linear. You check your feeder calibration. Frequently recheck it. And realize that different asphalts go through the meter differently and may have different calibration factors. If you're not plugged into this one point, then I don't know what you paid to come into this room, but just multiply by 10. That's the value of that one thing. As we go to high polymerized asphalts, as we change our polymer in our binder, it actually changes the way the meter actually measures. Okay, and so you need to be savvy to that. You want to check your meter calibration for the liquid you're running at the temperature that it runs, because they're frequently temperature sensitive. In other words, you take a high poly binder and you calibrate it at 285 and 325 and 345, and you're going to get 3 different calibration factors through that meter. So you better know that if you're trying to control AC within a tenth and a half, which is what all of us are trying to do. right? These are best practices. If you're using a gallon meter, you want to make sure your density is right, or your weight per gallon. Control automation's got a whole bunch of stuff. Who's that? That's the guy flying the plane. Make sure his moistures are right. Make sure the wrap moisture is entered into the system correctly for the wrap you're running, because some computers do not tag it to the mix formula. You move wrap piles, you've got to go to the parameter screen and say, I'm in a different pile and I have a different moisture. And I have a different asphalt weight per gallon. Or an asphalt content rather in the wrap. I said it wrong. So the AC will change in different fractionated wrap piles, and sometimes you have to tell, depending on the automation you have, I change piles in the asphalt contents differently, because it's going to weigh the wrap and it's going to say, this is how much moisture is in there. It's going to take it off, and this is how much AC is in that black stuff to control the other liquid. Target to actual again is really important. Stability of the flow signals is really an important thing. This is an example. I'd love to spend time with you on that, but we don't really have time. But if you look at the bottom line, this is a simple technique you can do yourself, which shows you on this example that the asphalt is moving in the mix, actually moving during production 3.1%, because the wrap scale has got built up in it on the head pulley, and it's moving 9%. The virgin scale is not. You clean the wrap pulley off and your asphalt stabilizes. It's all hula dancing together. So these are the things that producers that are good at what they do keep an eye on. And if you look at the chart in front of you and you look at the operator, you're going to see these points listed. In other words, you go through this program, and now I guess I could do a conclusion speech, but you go through this stuff, this knowledge, and you go, oh, yeah, okay, this is something. You look at that chart and you go, just do these things, dude. Or man, just do these things. And we're going to be okay. And then when it comes to maintenance, just do these things, and we're probably going to be okay. I have no idea. He's looking at his watch where I am. Now, don't bounce between mixes rapidly. 3 tons of this, 3 loads of this, 3 loads of that, 3 loads of this, 3 loads of that. These are continuous mix plants. They're supposed to be run continuously. Okay? It takes time for the plant to level out. You're going to have different stagger your start times for different mixes. Try to produce a solid load at a time. At least run it at least 100 tons at a time, because there's going to be a crossover mix. Because you're not going to shut the plant off. You're just going to switch mixes and keep going. Silo to silo to silo. These things are designed to run continuously. Run them continuously. Manage your schedule so you can do that. And that's not the plant operator's responsibility. That's the scheduler's, and management people need to be in the room to hear this one. How many management guys we have here? Okay. So, you know what I'm saying? It's somebody else telling them what to do. Don't raise and lower your ton per hour rapidly. If for no other reason than it takes time for your baghouse fines to go to your dust collector and come back. The time delay is 20 to 40 minutes. The bigger the dust collector you buy and the more screw conveyors you have, the longer that time delay. So you run at 300 ton an hour, you jump down to 250, you're still putting dust back in the 250 ton an hour mix at a 300 ton an hour rate, your voids are going to collapse. You go from 300, you go from 200 to 300 by putting in the same mix formula and call it something different, and then initiating a change. Aren't I clever, right? And they all know how to do this. Okay, dust is coming back at 200 ton an hour in your 300 ton an hour mix, and you're going to be short on dust, and your voids are going to open up. Okay, that's not quality management. So don't raise and lower your ton per hour. It takes time for everything to level out. Steady running produces steady mix. Memorize that. Steady running produces steady mix. And we all know this, because when we're in trouble, what do? Don't change production rate. Don't change mixes. Don't change temperature. Just run it and let's sample a couple loads and see if they're not the same. And somehow magically it just sort of helps. It's because these plants are designed to run continuously into a schedule. And we're just now beginning to wrap our head around it. And the reason is because now we're operating in a bonus world and everybody's chasing bonus. Okay? If we don't get at least, we got a 5% capability in the state that I'm working. We have 3 plants, we don't do that much mix. If we don't get at least 3% bonus on our mixes, there's usually a management meeting. It didn't used to be that way, but they have taught us how to run plants well. This bonus opportunity, and this is where all this stuff comes from. And you have it written down in front of you. And this is just the dialogue that supports it. Also, control your mix temperature 10 degrees. Plus or minus 10 degrees. Don't work with the minus. Usually we get 25 or 30 degree range to be in tolerance. It's the same as aggregate. That's just the acceptable range you can go out at. That doesn't mean you can go minus 20 and plus 20 at your target, because the field guys are going to have to adjust the density and their rolling pattern, and it's going to flow through the paper differently. So everything's going to change in the field, and field density is what's really, really important. You're the first step for field density. Control your temp. Who's going to do that? The guy flying the plane and the guy feeding the rocks in the bin. Stay up 12 inches, feed consistent, work the face, steady as she goes, treat it like a barge going down a river, not a speedboat. Hold that temperature, hold that rate. You check, rather your rate up, you got to adjust your burn. Run steady, run easy, steady hand on the wheel, and you can get bonus, and they can get bonus and smoothness out on the road. Okay? And that's what all these bullet points say. Load trucks, load them right. Square body trucks, it's a good idea to go front, back, and middle. Socket, I call it socket load in the truck. Mix consistency and mix trends frequently improve when you load the trucks right. And I've proven this, and I've been through wars and hell, even on half-inch mixes. And a lot of people say, well, half-inch mix won't segregate. Yes, it will. And if you're chasing bonus, you want to load trucks right. No matter, and there's a lot of different kinds of trucks in the world. Now, testing mixes, should you test them every day? The guys that are good do. They test mixes every single day, private or state or owner agency, because the guy that's building a new mall is just as interested in a 20-year pavement as somebody that's building a freeway. 0 time. Test and track your mix trends. We sell a lot of private mix. 3 reasons. We are the highest price by $10 to $15 per ton. Why do they come buy mix from us? FOB or sales? Because the mix is consistent, the mix temperature is consistent, we test every single day, and producers that are big into really improving their quality of business. Okay, every day. So the mix is a consistent mix at a consistent temperature. And the third thing is service. We call trucks underneath the silos. We don't let guys get in line and then tell us what to do. Okay? They are not in the yard more than 10 minutes, no matter how many trucks are there, because you can't pave 15 trucks in front of a paver anyhow. So with the apps we have now, we know our own jobs, how many trucks are in front of the paver. We will make sure everybody's got mix, and we're managing the dispatch and the guy gets it waved in. So they come in, they pay with credit card, they get loaded within 8 minutes, that's our target. And it works, right? So consistency of quality of mix is very important. Now you've got your data of your mix. The last thing is making mix changes. All right? How should you do that? Wait. Look for a trend. Don't make jackrabbit mix changes because there might be something might happen, an abnormality, right? Wait till you see a trend. If there is no trend, it's segregation. Okay? Send 3 trucks in a row, not in a row, but load 12, load 14, load 16, compare results. If you ran steady in the same mix, you didn't change production rate, there isn't a person in this room that doesn't think that those mixes automatic. They might be bad, but they're equally bad. You go fix your problem. If they are not, and they're okay, or of course we're fine, you have a segregation problem. 80%, write this down, because we're gonna have to let the slides up. 80% of this segregation problem is gonna happen in your batch. Didn't feed the middle, got a hole, A doesn't close all the way, A stays open too long, etc., etc. Whose job should look at that? The ground guy. It ain't hard. There's inspection doors you can look in when it's running. Okay? So don't make a mix change just on one test. Wait for a sample and then make a change when it's trending. The rest of it is going to be, this is the maintenance part of the program. You've got the list in front of you. There's some examples in here about mix problem that are the result of maintenance. One is your dryer flights are shot. Can't dry rock, can't hold consistent temperature. Other one is your bag house is not working right. You're over dusting or under dusting your mix. Not because of the guy flying the plane, but because the machine is not functioning right. Those things are listed in that chart in front of you. I hope you guys think it was worth investing your time in letting me make this presentation for you. I appreciate it. Good luck. Have a great show.